What's poppin', dogs? Mr. Allen here with some solving of polynomial inequalities when we are given the graphs of our two functions. So let's start over here with the purple one, g of x. I have a cubic function and it appears to be negative because it's going down and to the right. And I've got these four different scenarios. I find it helpful when teaching to go over those four scenarios because it's like, wait, what if it was equal to? What if it wasn't? What about this? What about that? Let's just do all four, right? That way you're prepared for anything. So first off, g of x is greater than 0. So verbally, and graphically, what does that mean if I'm saying g of x is greater than 0? Well, that means that it's above, right? Above the x-axis, right? Positive. So where is it above the x-axis? Well, all of that is above the x-axis. But hold up. That point and that point are on the x-axis, which means it's equal to 0. So we have to omit those. So I'm going to do this in interval notation. I find it easiest for this. We got 1, 2, negative 2. So from negative infinity to negative 2, negative infinity to negative 2, not including them, it's above 0. And then from 2 to negative 2, to 1, 2. So from negative 2 to positive 2, it's also above the x-axis. But we're not including negative 2 because it equals 0 at that point. So this would be where the graph is greater than 0. That's it. Those are the only two intervals where that's happening. I will do this one in inequality mode, if you will, just so you guys can see that. But otherwise, I'm going to stick to interval notation. I feel like it's easiest with these. So here would be when x is less than negative 2, and then when x is between negative 2 and positive 2, not including. So that would be the equivalent in inequality type form versus interval notation. Your call on what you want to use, or if your teacher's specific to that. I usually just let people choose which one as long as it's correct. I'm cool with that, okay? But that's just me. Not every teacher is the same. So let's go down to g of x is greater than or equal to 0 for the next part, okay? Because it does change if it's equal to or not. There are some different weird things going on here. So for this one, when it's greater than or equal to 0, that means I'd include this point and that point. So now I no longer have to break this thing up because it's greater than or equal to 0 here. It's equal to 0 here. It's still greater than 0, and then it's equal to 0. So for this one, I'm going to be going from negative infinity to positive 2, and I will include that 2 with a bracket there. Okay? Bippity bop. All right, I'll do one more with inequalities just in case. This would be x is less than or equal to positive 2. Okay? So those two things mean the same thing. All right? So now on to g of x is less than 0. Well, where is it less than 0? Where is it below the x-axis? That would only be on this stretch here. So when my x values are greater than positive 2, so we could write it like that, or you could say from 2 to positive infinity. I keep lying. I'll just do the inequalities again. I've done it already. This would be when x is greater than positive 2. All right, so either one of those would suffice here. I should have just said I'll just do it. I got the room. It's exciting. A lot of colors. It's cool. So just when it's greater than 2, or when it's from 2 to infinity, that is where my graph is less than 0, right? How about g of x is less than or equal to 0? Ooh. Just that stretch? What about that point, dogs? That is always a tricky one. It's easy to miss that. So we got to include negative 2 and just negative 2, and then from 2 on, okay? So in interval notation, I see some teachers write it like this, negative 2, union, and then positive 2 to infinity. I'm cool with that, right? With the inequalities and whatnots, I'd say something like x equals negative 2 and x is greater than or equal to positive 2. That would work, okay? So those are my two spots. We got to include that point because it is equal to 0 at that spot. It's easy to forget that because you're like, no, I'm just looking at this section. This is where it's negative, right? But don't forget about that guy there that's bouncing off of that x-axis. All right, first one done. Now let's do the quartic function, 4 scenarios. Once again, this is gonna be exciting. Okay, so I'll use blue. Actually, you know what? We'll stick with the same colors. Interval notation in green. All right, so f of x is greater than 0. So where is it above my x-axis? Well, it's in this section right here, right? But a similar idea, I got to omit this point because it's equal to 0 at that spot. So from negative 3, right? 1, 2, 3 to positive 1. So negative 3 to positive 1, and then we'll pick it back up at 1, so union 1, comma, and then it goes 1, 2, 3, 4. Boom. That is where it's greater than 0. This is where like the inequalities get kind of long to write, I feel like, in these situations. So we got two compounds, right? Negative 3 is less than x is less than 1. And then 1 is less than x is less than 4. One thing to point out, guys, the inequalities will always point to the left in a compound inequality scenario. So remember that? They'll never point away like this, okay? They always point in the same direction, which is to the left, to the left. Beyonce reference, I think so. Correct me if I'm wrong in the comments. Like, no, Mr. Allen, wrong. I'm pretty sure it's Beyonce because I think I said Riri, Rihanna one time in a video, and then a student of mine was like, Mr. Allen, it's Beyonce. I'm like, oh, okay. So, or it was the opposite. I don't know what happened. Anyways, let's go with greater than or equal to 0 now for this one. So greater than or equal to, well, now I need to include this point because it equals 0 right there. And I am going to include those two, but now just one interval from negative 3 to positive 4. So, oops, bracket, negative 3 to positive 4, bippity, boppity boo. And then for inequalities, it's just going to be from negative 3 less than or equal to x less than or equal to positive 4. Boom, bingo, wonderful. Next one, f of x is less than 0. So when is it below the x-axis? Well, it's below it from negative infinity to positive 3. So negative infinity to positive 3, not including it, right? And then it is below 0, right? F of x is less than 0 over here. So at 4 to infinity. So union 4 to infinity and beyond, Buzz Lightyear. Now, how about in inequality form here? I'm going to be x is less than 3 and x is going to be greater than, less than, did I forget a negative there? Oh my goodness. Mr. Allen, negative. That was close, you guys. I could have lost some points there, right? And then greater than 4. My apologies. So we have from negative infinity to negative 3. We have from 4 to infinity. And that's the same thing as saying x is less than negative 3. X is greater than positive 4, right? Cool. You put an or there. A lot of times, though, with these, I'm just like separating them with commas just to list out all those inequalities. Again, check with your teacher if they want any specific proper notation. Sometimes I'm street mathing out here. I'm just trying to get the information across. Sometimes math teachers, us math teachers, a little too hoity-toity on the notation. Like, calm down, bro. Just want to. X is less than negative 3. X is greater than 4. You understand what I mean here? I'm using some nice notation. Maybe I didn't have an or, whatever, like those fancy brackets and. Sometimes it's too much, man. Too bougie. All right, last thing here. X is less than or equal to 0. Well, it's still going to be this part and this part, but it's also equal to 0 here. So, hold on here, dogs. Hold on. We have negative infinity to negative 3, including it, union. Then here at 1, we'll do the little fancy bracket around 1, union, and then from 4 to infinity, including that 4 to infinity. Woo, just enough room. And lastly, but not leastly, that's not a word, I've got it as x is less than or equal to negative 3, x equals positive 1, and x is greater than or equal to positive 4 for my two different ways of writing this, because Mr. Allen has got your back on whatever notation your teacher wants you to use. They both have their place in mathematics. I prefer interval notation, like I said, in these scenarios. But hey, sometimes inequalities, sometimes that's just, the way to go, man. Or like, especially with like rational functions, when you start omitting these from domains, like just x doesn't equal this, like then that makes sense, right? So sometimes interval notation works, sometimes the other one works. I prefer to choose whichever one is just cleanest, gets the point across best, okay? But here you go, guys. Polynomial inequalities given a graph rather than given a function. That's a whole different kind of thing here, but I think the graphs, you're allowed to look at it. You can kind of analyze what's going on. All right. Hopefully that helps you guys. If you have any questions, pop them in the comments, and have a dope day.